The topic I picked was one that I hope is of interest to a fairly broad set of audience. We get quite a variety of folks. So do we have any developers in the room? I know we've got some. Developers? Okay. Infrastructure folks, more focused on networking and security, a little bit DevOps, maybe, some a little, okay. Yeah, just all of it, everything. Yeah, I know, yeah, all of it, yeah. Security, yeah, we do that, okay. Data and AI. Okay, hands down on the data and, okay, right, no databases, no AI, no cognitive services, none of that stuff yet. Okay, maybe a little bit. So yeah, some of that. So did I see some other hands up for databases? Yeah, okay, got some other database folks or back-end data store folks. So yeah, a bit of everything. So, and the intent of actually tonight's discussion is really meant to be general. There's a number of services in Azure that support APIs, and so that is the intent of what we're talking about. So going back a long time, we're a little trip through history for some of those, because that's also something that I've seen working with users of Azure. There's some really old code out there. I mean, some of it is just ancient. And there are services in Azure to support your absolutely ancient code. And there are old ways of doing it. And there are more modern ways of doing it. So we're going to actually start like way back in the past, how you might have done it in the past, and sort of move towards some of the ways that you can host and use APIs that you built, or even build APIs using Azure services today. And back in the day, a lot of developer skills were required. I was a professional developer. I slung code for over a decade, mostly as a consultant, most of it. And so wrote a lot of code, including a lot of code for APIs. But what we'll see, and we'll talk about some of that, because that's still necessary or still an option, right? Writing code. But also you can use other technologies that don't require developer skills. You don't actually have to be a developer to write, a professional developer with a comp sci degree in order to write APIs today. Now you can use scripting languages like PowerShell in order to actually write APIs, something that I've seen customers do. I'll share some anecdotes about some of those as we get through to those. And then, and you can still do that. And then we'll get all the way up to some of the newest technologies available to everyone in Azure that don't require any code at all, no developer skills whatsoever, and you can still have APIs served up against data stores. Again, so we'll talk about those, have some examples of some of those, and how you might wrap some of those. So I have a minimum number of slides. I think I have, how many slides do I have? I think I have like 6 or 7. Oh, there's the number, 10. I have 10 slides. And most of what we have is just examples and demos, and I welcome questions and interaction. It's not, because that's more fun, frankly, if we talk about it, than it is if I bore you to death with PowerPoint, because who wants to do that? So,
Adam, I have a question.
Yes, ma'am.
First of all, well, it's a two-part question. How did these Azure meetups start? Because I remember a little history. And where did you get that suit?
You are not the first person to ask me where I got my suit.
I want a selfie. I'm saying.
I would love that. Yes.
So I had the great good fortune to work with this man when he created these Azure meetups.
Yes, 2016.
I'm the calmly dressed one. But so you all know that you've invested your time well. It's not just his suits he's passionate about, and he's got a wardrobe of them, although this tops anything I have ever seen.
Oh, thank you. This whole thing.
This is not his day job. This is his passion. And he's here because he wants to be here and he wants to engage with all of you and he wants to create a better community. So I hope you all have a great time. Really enjoy it. You got one of the best, really. And I'm still going to post that, just so you know.
Okay,
right.
Thank you.
I wish you didn't give your body.
I could
That's
not
true.
do that. I like him too much
She
for
would
that.
not. All right. Okay, so Again, not expecting everyone necessarily to know what an API is, right? And so again, broad audience. So we're going to touch upon what it is at a high level. Does anyone else want to tackle this first? I know there are some developers in the room. What is an API? Application programming interface. Gentleman at the back.
Yeah, it's a application interface where you can make requests to it and retrieve data, and it has a whole variety of different kinds. You can make your own or use a lot of API tools that a lot of companies provide.
Yep, good enough. So what systems talking to one another, right? I remember, I've been doing this a long time. Some of the earliest ones was like email, right? You had a thick client email application and you needed an email server and they needed a mechanism of talking to one another. And that wasn't called an API then, it was just some kind of connection. And then it moved to others like databases. They have a classic connection from a thick client to the back end. Again, not an API, but an early version of it, right? A way of something, a system, a software system talking to another software system. And then technology evolved. We've had lots of standards. Does anyone know some oil and gas folks? We've got like energistic standards for those of you, that's very Houston specific. So energistics are APIs that are specific to the oil and gas industry to provide interoperability. And then that's supported by like PPDM, which are database formats or schemas, that, again, to support oil and gas industry. And then technologies like XML, or WITSML. Anyone know any WITSML aficionados in the room? Some nodding. Yeah, I know, WITSML. Yeah, that was a fun one, right? Well, still is. It's a form of API, not why it's a standard. Varying degrees of difficulty using with it. You might have some scars. I actually have some scars. Used for integrating different systems. And that's commonly what they're for, right? All these technologies have been invented over time for a software system to talk one another in ways written in different technology stacks in ways that are easy and convenient at a high level, right? And the most recent ones we have are RESTful APIs, and those have been common for a while. And there's all kinds of technologies, like you were saying, to help write some of those. I learned about one today from Brian. He was telling me about one. It was Fast API, yeah. Another, a tech stack to make it easier to write APIs. There's lots of them, been all kinds. None of those technologies really have a whole lot to do with Azure at this point, because the Azure is more infrastructure underneath the covers, right? And so Azure doesn't, generally speaking, doesn't care what those technologies that we use to build it in, but we want some technologies to use in order to host them. And that's what we're gonna, and build them as well, right? So that's what we're gonna focus upon. Not really how to build an API, generally speaking, using some of those technologies, although there are some Azure technologies that allow us to build APIs without code. I mentioned some of those. We're going to see those. Logic apps. Anyone know what logic apps, familiar with logic apps? Expert logic apps users? Okay, some expert logic apps users. And so we'll touch upon those. That's a way of writing APIs without code. Functions, we're going to talk about those a little bit. Yeah, okay. Another way of serving up APIs, again, with or without code. We're going to talk about some of those options as well, before we get to some of the most recent capabilities that use neither of those. So I was going to show this real quick for anyone that, let's see. Again, the audience might vary quite a bit, so not everyone necessarily. There's not an expectation that everyone knows or has a development background or knows what APIs are. It's not an expectation from this group. And so I have a UI on screen. Oh, you know what? Yeah, I realized it's not being shared, is it? No. Do not have a UI on screen. Okay. No, don't. So there is, as I mentioned, APIs, generally speaking, right, are for systems to talk to other systems. And so it's not something that humans interact with, right? Humans, we don't look at APIs, that's for systems. Systems care about APIs, we humans don't. But when developing APIs or visualizing them, we need some mechanism to visualize them. There are some open standards in order to help with that, and some tools. One of the easiest tools within Azure to help with visualizing APIs is a service called API management. And we're going to spend a little more time on API management a little bit later, but what my purpose right now is just to use some of the features of this tool to help anyone who's new to APIs just understand a little bit more about what they do. That's the purpose of this. We're not diving into the features of API management just yet. We're just trying to get a feel for what an API is like as a human and why we care about it. Again, not expecting everyone to fully understand necessarily everything there is those. So I have an API in order to be useful to applications. And I meant to mention one of the most common use cases for APIs is web apps, right? Is mobile apps. So every app on your phone it's a system, it's a software system, and it needs to talk to something in order to do much of its stuff, right? And so what typically it needs to talk to is, of course, some APIs. It's a system running on your phone, talking to another system running in the cloud, Azure, AWS, GCP, usually, right? Invisible to you as an owner of the phone, don't know, don't care, it just happens, it just does it, right? And that's one of the most common use cases for APIs. So you never need to know what it does. But as a developer, when you are looking to use APIs, data served up by a data store, SQL database, SQL Server, Cosmos in Azure, Oracle, or wherever the data might be, you need some mechanism of serving up that data that doesn't mean that you're directly connecting to the data store. That's how we used to do it in the past. I don't know. One of my first applications in the 90s was one of the early websites, IAS, talking directly to a SQL Server. Question?
Unrelated question. And this screen be turned on?
Why is that screen not on? No, it can't. I don't know why that is not. So no, sorry. If you want to move to this side, then yeah, sorry, I didn't realize that wasn't on. Okay, I brought up an example API just to, again, for anyone newer to help understand some of these concepts at a high level, using a UI to describe an example. So there's some common examples to help developers looking to understand some of this technology, which we're not going to get into right now. And one of them is a pet store API, because it's easy to understand what a pet store might be. You look for pets, you add new pets, and you can see various methods or things that our API does that make sense from a human perspective, right? So we're going to add a new pet to the store, we're going to create a user, delete users, delete pets, and so this find pet by ID, you can see these human readable, what's called methods or function capabilities of this pet store API are things that we can have if we were, for example, building a web app, an app on my phone, or I wanted to get this data. For whatever business reason, I have another application, I need to retrieve this data, load it, do something processing with it. There is some data in this pet store system that I need to retrieve, and I don't have access to the database. I need to get through an API. And so there are some methods created for me that define those. And so this visualization is a way of understanding as a human what those APIs do so that I can craft my software application to easily do it. And so this UI allows me to test them, for example, find pets by status. So I can do a test of this. And the various features here, and I'm going to test it. I'm going to test this one. Allows me to take some data that this API expects. So I'm going to do a test of all pets that are available. So find pets by status, and the status I sent in was available. I make a call to that API, and then I get results back. So this is data, as you can see. There's some right here, and technology called JSON that represents a pet from this particular backend store. Again, we don't care what the backend store is. That would be something perhaps traditional, again, like an Oracle server, something more modern. We don't really care. It could be a file system, could be something ancient, could be, I don't know, who knows? We don't care. This API hides that from us. And so with access to this API and an understanding of what it can and can't do, we have the ability to make requests to it and get back data that we care about. And that, at a high level, is what an API allows us to do. And what I'm showing here are some features of API management that allow humans to test and validate APIs that are available to them. Does that make sense? Any questions on this thus far?
Why does the data look like the method names?
Why does the data not look like the method names?
Is that really sports league?
Oh, no, this example is a pet store API. And I also have some sports league APIs that I'll demonstrate on this particular example. Sports league is another website that sells sports equipment.
What kind of animal is a Jerry Johnson?
Don't understand.
That's what I see.
Oh, yeah. So we can't, I mean, this is the data the system turns back, right? I mean, it's whatever we get. It was in the data store. Someone created it. Who knows? I don't know. But yeah, right. Could be any kind of junk, whatever. Data, good or bad, that's not a problem that the API solves. Getting the data to us is what it solves. It's up to us then to figure out what we do with it. And that's the purpose of, again, the APIs. So I'm skipping over a lot of weedy tech here deliberately, because I don't think that's not the focus of what we're talking about here. Let me put this back. I actually think I'm going to do.
Is it fair to think about it as, so when you have an API, you think about different operations you want to do and kind of chunk it that way, so that when you're trying to explain it to someone, you're accessing this API, you're working with it, it's not some technical thing you're doing. It's, I'm doing an operation that's going to give me something valuable. And that's how you want to organize APIs into these kind of operations.
Yes.
I like to think of it, an API is how one program talks to another.
Right.
Or whatever.
Right. Yep, and that's it. And usually to get data, right? The reason the program is talking to another program is because it wants to send data or get data. That's the full purpose. The example we have up here is regarding pets. We want to know pets. We want to create pets for the purposes of this pet store that, again, we don't care what the pet store looks like or how it works. I mean, there's going to be a website there. There's going to be an app on a phone somewhere. Again, we don't care about any of that. This is just at the API level we're focusing right now, and it's mechanisms for sending data to this pet store behind the scenes and fetching data for whatever purpose that we have. I have another example. So my sports league one.
Could it also be considered as like an abstraction layer in simplicity? Like, yeah, you got two APIs talking to each other, for example, two different systems, but could you, and I've been thinking about this, like, could you consider that as like more abstraction as well, like abstracting away the complexity by using APIs? By giving like a, easy interface to talk to a system?
It is an easy system interface, yes, which is actually something I was going to show next. So that was a nice segue, a mechanism of hiding complexity, indeed. So what I have here is, let's find this, into Azure right now. And so I briefly showed one of the Azure services, API management, for the purposes of helping explain what a API does. Let's look a little bit further into, just to help, again, for the purposes of understanding what an API does and why you might want one. Let's look at the most common use case. So we mentioned that there is a need usually for APIs to fetch and send data to backend data stores. On screen now is an example data store. This one is a SQL database. And ordinarily, if we're writing an app for our phone, we would not care that this is SQL database. And that is the point you were making about abstraction, right? So inside this is the core data that we care about. Let's see, I can log in securely. And I can look in the database if I have permissions to do so at, for example, the orders right here, right? So I can select 1,000 rows of very raw data using some tooling provided by the Azure portal here directly against this backend data store. Now, this is the data right here that represents orders that an app on a phone, a website, for example, would need to send and retrieve. And traditionally, without APIs, you would used to directly call the SQL database or backend or whatever it is and manipulate this data. That's how it was done in the past. But that means a lot of understanding about how this database works. You have to know that it's a SQL server, and there's all kinds of security issues with that. What you really want to do is hide the fact that there is a SQL database at all that actually stores this data and provide a mechanism for securely accessing this data without anyone needing to know about this database at all. So that's the the hiding or the facade pattern. And so to do that, for example, you would have an API. And so get orders, for example, like this. You can then make requests against this. I can't remember if this is actually working or not. I don't have authorization set up, but if I had this hooked up correctly, then I could use an API which would then read from that database and provide data to whatever's calling it. And so what we're going to look at next is a few ways of providing that abstraction, right? So given that we have this data in our SQL database, so there is some backend data store. In this case, it's SQL database. We're just going to go with that. And we could use another one. In fact, I also have it in Cosmos DB as an example here. And that, let's say, from a business perspective, is the canonical, that's where the data is. That's where it needs to live. That's the core business system, because there needs to be a single source of truth for any given data, for any given business system. In this case, Sports League is another website, because that's easy to understand for the purposes of example. And the data lives in a backend data store. Again, in this example, it's SQL database. Now, this particular example, I'm going to have a little bit of fun with it, because this one is a really, really ancient website that I think somebody wrote well over a decade ago as an example of when I think ASP.NET was like the leading edge technology. It was just the greatest thing ever. And SQL Server was also just, that's what you did, that's what you used. And the original version had a website in ASP.NET that actually talked directly against this very SQL database. And so I have some very ancient code that can show an evolution, right, of how leaving this data in this database, we're not going to take it out. Well, we could put it in another data store. And in fact, I have an example of that for Cosmos, but in most business situations, you need to leave it in a data store, and it just gets bigger and bigger. You can't move stuff around very, very easily because there's a lot of dependencies on it, right? So given that we need to leave the data in there, we need some APIs in front of it to make it easy to access and read. And we have a whole slew of technologies for actually creating those APIs, and that's what we're going to talk about a little bit more next. So that was what is an API. I meant to do. Let's see, let's do that. Okay. No. Okay. So given that we've created an API, and again, the technology for actually building APIs is something we'll talk about in a minute. Right? We're going to talk about building APIs, but first off, we're going to talk about just some of the technologies for hosting APIs. And these might be really ancient, crusty ones, like the one we're going to look at in a minute, or maybe some more modern ones. Again, it's a journey. There's some really old code out there that just hangs around and persists. We've all seen it. I mean, it's out there. Web apps is the OG original hosting service, platform as a service for hosting APIs. There was even originally, in fact, I was at the launch of Azure in 2010. Web apps were there. Virtual machines were not, incidentally. Virtual machines came out in 2011. Web apps were there, and there were two flavors. There was web apps and there was API apps. And the only difference between them was the icon that they showed in the Azure portal. So that went away. But web apps did not. They just became web apps, just the one thing. Various flavors of them, and a lot more features have been added over the years. And so we can use web apps in order to host our APIs, and that's a completely legit way of doing it even today. So let's go and look at one. Let's see. Okay, I have a static web app. We're going to come and look at that one in a minute. Here is my data API web app right here. So many of you, you expressed that you know about web apps. The feature set for this thing is enormous, but essentially two flavors, Linux or Windows, auto scaling, and basically a web server as a service. So this can also be used to serve up a human-facing website, and many such websites are served up in that way. But also, if you have older code, can serve up APIs. So this is an example, and this particular one I've hooked up to my really ancient code in Visual Studio, which we'll go and laugh at in a minute. There's a lot of configuration options, which if there's interest from folks in the crowd, we can dive into. Honestly, we could spend the entire few hours just going through the features of this one service now. But I don't propose to, unless there's some interest in here. But generally speaking, the way this one is configured does not follow very many of Microsoft's very own best practices. It has application insights, which you should enable and is enabled by default in order to capture logging and telemetry information. It doesn't have, let's see, I think I've cheaped out on the app service plan here. Yeah, basic, so that one's going to be particularly slow, and manual scale. So again, not best practices, right? It doesn't have a custom domain, but could. It comes with one out of the box. But let's look at some of the other configurations to see some of the things that we could and should have enabled on this, because this at this point is infrastructure for hosting code that you wrote. So you have settings here which appear as environment variables, including one right here, which is a connection string to that very SQL database we just showed. Let's see what else we got.
Question here.
Yep.
If I may. So is this the app service or is this the web app? It's the same thing. I'm brand new to Azure. So.
Okay, that's exactly why. Who was asking that? I wasn't looking. Okay, so app service is configuration, essentially. And that's what we're looking at right here. It's a whole bunch of settings for where my code is, what the domain name of the thing is, and how I want to secure it, whether or not it has what framework it's running, things like that. And then what it isn't is the infrastructure that actually powers it. So it is not the CPU and the compute. The web app has that. Behind the web app is what's called an app service plan. So it's actually, there are two components to every web app. And the web app is the bit that you see. That was the bit that I clicked. That's the bit that has all the configuration. It's the bit that you hook up to Azure DevOps or GitHub to deploy your code. It's the bit that has all the configuration. So that it's what you see and care about. But the app service plan, and there is a link to it from here, is actually a separate piece. So if I think let's find it in here. Is it in the same app service plan? See, has a random name of type app service plan, this guy right here. And so this thing is a separate resource. And so this is pure compute. This is what you might think of as a virtual machine, traditionally. This is what powers your code. It's also, you choose Windows or Linux. You choose features like zone redundant right here, which means it's in separate physical data centers. So that's high availability at this point. So this is very much pure infrastructure at this point. It is a component of the infrastructure. And this is also the bit you pay for. You don't pay for the web app part. The bit I just showed, this is actually what appears in your bill. This is the bit that does all the work. It's the piece behind the scenes. It's the engine that runs your code. And it can run many web apps. So you can stack a bunch of web apps, like the one I just showed, on one app service plan, if you would like. They have to be common. So things like the operating system, you choose that when you create the app service plan, like here. So this example is Windows, for example, in this particular case. So all of the web apps connected to this app service plan need to have Windows websites running on them. And this app service plan, it's running Windows behind the scenes, will run as many as you wish to put on it that the horsepower that you've paid for will allow. And there are the same scale up. I showed this scale up, scale out link on the previous page of the web app. This is actually where it's configured on this app service plan. You choose basically the amount of horsepower that you want. So the number of virtual CPUs. So very traditional virtual machine or infrastructure as a service like concepts. So how many CPUs do I want? I want up to 4. How much memory do I want? I want 14 gig. How much storage do I want? And so on. And you configure all of those pieces here. And this is the bit with the bill attached to it. So, makes sense? Again, absolutely nothing to do with APIs at this point. But that is one of the reasons I wanted to cover this, right? This is the bits that's underneath. We're not talking about necessarily building APIs. This is, some of the logic apps and functions we will, but this is the infrastructure that once you've got your beautiful API, you've coded it, or in the case often of web apps, you've inherited it that somebody else wrote a decade ago. That also happens a lot. Anyone else inherited some really ancient code? Anyone else done that? It happens. I mean, code is around for a long time. Unless it's been designed for some of the more modern infrastructure services that we'll talk about in a bit, then you host it on something like this. So this is better than a virtual machine, right? That's the base. I've skipped that. Don't do that. Just put it on an app service plan and configure the horsepower and security features that you need. And I've skipped over many of them. I was going to hover over one example. So going back to, so that was again my app service plan. And here here is one app service. Again, could be many app services against the same app service plan. There's all kinds of authentication features that the infrastructure supports that you should be aware of, that I'm waiting for this to come up. Come on.
Does the service plan, things have to be registered with it, or does it know the things that are available to be of use?
So you need to register the web apps that you have, that you want your app service plan to host. So you can create an app service plan and you'll get billed for it, and it can sit there and do absolutely nothing. You can just create one if you'd like in the Azure portal or CLI, whatever you like. You need to tell, in fact, the way it's done is you create a web app, and then you have to assign an app service plan to that web app. It's a requirement because it needs some horsepower to run whatever you've put on it. So does that answer your question, Ray? Yeah.
Let's say that we're getting data from a database.
Yep, like the SQL database we've got right there.
Now, does the database also have to be on the service plan? Or just be available to the service plan? Does the service plan just have to know about it, or does it have to be part of it?
Okay. So your question is regarding the backend data store, which was actually one of the reasons that I showed it, right? So we have the backend data store, which was this SQL server or SQL database right here. This has got absolutely nothing to do with that app service plan. Zip, zero, nothing, utterly, totally independent. There doesn't need to be an app service plan or a web app. This database does not care. App service plan, the purpose of that is to power a web app which hosts our code, which runs our API. That is the purpose of that. Now, there are some places where they need to be linked together, or can be, and I'm being careful to try not to go too far into the weeds, because there's a lot, given the time here. So I will call out this. There are a lot of security features that app service plans have that you should use, that I'm not going to spend too much time on, just in the interests of time today. One I will call out, because you mentioned it, Ray, is a need for authentication to the database. So there needs to be a mechanism to sign into this database. This code needs to have permission to read from this database, right? It's an API. It needs to have that. Now, traditionally, you would have that as a connection string and an environment variable. I think I showed one just now, right? That would be in configuration, and a connection string, just a secret, a password, right? And there's here, this one right here, this value right there is a secret, a connection string, a password to my database. That is not the best way to authenticate to that database. The best way is to use what's called a managed identity. Now, this is an infrastructure security component of many Azure services that it's not enabled by default, it's off by default. You need to choose to use it, and you should. That's why I'm calling this out. It's off by default. I put it on and in the Azure portal, and what it does behind the scenes is create an object in your Azure Active Directory that represents this web app. It's an object with no permissions at all, nothing. It simply is representational of this web app. You then give that object permissions to Azure resources using an account that has the permissions required to give this object permissions. In this example, you can see I've given this object reader permissions to my SQL database. So instead of having secret connection strings or dealing with that, or having people worry about it, or needing to secure it, or all those kinds of traditional headaches of having a password stored somewhere or not, instead we've used this infrastructure capability of web apps to have permission to the SQL database. And then that means we don't need passwords in our connection string. So the developers need to know that this is how we are authenticating with our database. Just totally happen by magic. It needs to be some awareness in the code, and whatever tech stack you're using, that this is the approach and passwords are not required in order to authenticate. There are SDKs in whichever language you're using to enable this magic to work. What it means is the code doesn't need to look for a full connection string and then use it. It will instead use this infrastructure feature to get access to the database. And permissions then are controlled right here. So this reader, this is what the permissions to this database are, which means that if my code needs to write to this database, I need to change this permission. So this is a much more secure way of providing authentication to other Azure services from your code at an infrastructure level. I wanted to call that one out because this is an important infrastructure feature that pertains particularly to APIs, because APIs are almost always talking to some kind of data store in order to fetch and receive data. So that's why I'm calling that out. Some services like, this is using modern authentication, doesn't work in all scenarios. So for example, Oracle, it does not work. Oracle requires domain joins, traditional AD, this is not that. It's not traditional AD, which you might be used to on-prem. It's not that, it's something else. You would need to, you would be able to use this mechanism to talk to an Oracle database. But other Azure services, Cosmos DB storage accounts, other services that support Azure AD, you can and should use this mechanism to retrieve data from. All right, any questions on this?
So I see there's no password, but like what's the,
Right.
I'm thinking you don't provide an IP, but it's just, how do you get the address of that service?
Okay, so yeah, your question is, the code has to know what the name of the
Where
server
am I
is.
putting it?
Yes, that is as part of, that actually is what the connection string does contain. So the code still needs that. What is the name of my server? Still required, and you'd pass it in as an environment variable, but typically the name of the server is not considered a secret, so we're not going to worry about that so much, right? And that is all the connection string needs to contain. What's the name of my server? And that's it.
Integrated security equals true? Not even integrated security equals true or old school?
Integrated security is true is traditional domain join. This is a different technology to traditional domain join. So that's an on-prem, that's Kerberos, that's that technology. This is not that. Web apps don't support that. This is not Kerberos. This is modern auth.
Okay, so this is .NET Core only.
Now you can, it's not .NET Core only. It can, any language you want. There's SDKs to support it. Yep. This is effectively OAuth against using your Azure Active Directory to provide the security for you. I'm trying not to get too much into the weeds because this is a deep topic. I'm trying to move along, but yeah, but I also want to make sure I answer your questions, Joe. This is a technology by itself, if you will. Managed identity is a technology that's across many services in Azure. And VMs support it. So you could have your code running on a virtual machine, you would enable a managed identity, and you could use that identity to read again from the database in exactly the same way. So it's not domain joined, it's not Kerberos, it is like that, but it is an internet capable version of it. Because we don't have Kerberos in these PaaS services. We have Kerberos, traditional AD in VMs, in IaaS. This is all PaaS, doesn't have that. SQL database doesn't have that. Web apps don't have that. So this is what we have instead. Okay, I'll keep moving along because I don't want to get bogged down into too many weeds. I'm trying to touch on to just a few things that make sense specifically for APIs. But I mean, again, welcome the discussion. We're here to learn, right? That's the intent. Let's see, what are the general settings do we care about here? So we pick the technology stack for the code that's running our API. Again, remember this also could be working websites. So we've got a .NET code right here, but it could be Java or it could be Node, whatever we want. Let's see, and this particular one, there's a that pertains especially to APIs, right? So on a website, then you would have authentication via username, password. You want your guests to sign in, and web apps can do that, but we don't want our APIs to necessarily have to sign in. That is a capability that we can have. One easy way to lock down APIs is to use a technology called client certificates, which is a certificate, like an SSL certificate, a component, a securely created component that is very limited so there's only one of these typically, and you have a great deal of control over where that certificate is. You can configure web apps to demand that you present a client certificate in order to continue doing on as a security precaution, right? And that is a good way to protect your APIs, particularly behind a service like API management, which is you don't want just anyone under the sun talking to your APIs. You want to protect those. And so one way to protect those is to put them behind API management, which we'll talk to a bit later. And a great way to ensure that only API management is talking to your APIs is to enable these client certificates, which is, again, this is an infrastructure feature. I'll actually just say that this could be done in code, and actually so could the authentication we just talked about could also be done in code, but these are infrastructure features to make your developers' lives a bit easier. Okay. I feel like I'm spending too much time on this one, so I'm gonna move along. I was gonna just show some of my, I had some incredibly ancient, oh, that's right, incredibly ancient code. Where did that go? So on this thing, again, trying to, the purpose of showing my really old code here is how APIs might have been written back in the day and still can be to some extent using very old tooling. I think the last time I touched this was 2018. It was really, really old, some of this, 2017 stuff's old. And it was, it was a bit old even then. So a ton of code. Again, the purpose of this is to show how much code was actually necessary to build all of these APIs. So orders controller, for example, we've got just a ton of code in here that I needed to write in order to call against the database and fetch the data. So this is just doing the work of an API, a system, abstracting, getting the data and sending it all back. So lots and lots of code, and back in the teens, there weren't many other better options than this one. You heading out, Kim? You heading out? Okay. Okay. And so again, what I'm trying to share here is a ton of code. And what the progression I'm intending to show is we need less and less code with some of the newer services that I'm going to show. So this is the past. This is how it used to be, and can still if you want. Like I say, there's a lot of old code out there, and this is one example of that works just fine on a web app. Yeah, this is great, and you have lots and lots of methods. So again, we've got categories, order details, products, a whole bunch of functionality that relate to an e-commerce site. That's the example API we've got here, all relating to that one database, right? All sort of piled together and all running on one web app. So that works, and this is how it used to be done back in the day, and still can if your code is really old. A couple of problems with this is if you want to make some changes to one of these methods, you have a whole ton of code to rebuild and then push to your web app. So there's all kinds of fragility issues and reasons why we don't do this anymore. This is not how you'd make APIs, irrespective of what code. This code is C#. We wouldn't do this anymore. We would use some of the other more modern technologies. So I talked about, so that was trying to cover off web apps. Still a valid solution, but more typically for older code. Web apps also support containers. If you have containerized your code, again, we're talking about APIs here. I'm not going to dive too much into the technology of containers. Another way of encapsulating your code, and I'll really leave it at that. There are also other Azure services that can host containers. So if your API, again, just flipping back to my example code right here, if this was built and compiled and running on container technology, and again, not expecting everyone to know what that is, just for the purposes of just helping maybe some folks who are new understand. If we're using container technology, and we could, then there are a number of technologies in Azure that could host it, including web apps. There are some others as well. Not going to dwell on those because, again, we're trying to focus on APIs right here. So containers is an option, and containers in web apps is an option. A more modern solution, though, might be static web apps. And we're going to spend a little more time on this one because this is one of the more modern infrastructure options for hosting web apps. So I'm going to move away, just going to ignore my web app right there with my ancient code running in it. Again, my ancient code is still talking to that SQL database. The SQL database isn't changing. The way in which we're using infrastructure in Azure to host code or not code to read from that database, that's what's different. So we have, for example, static web app. Where did that go? I have so many things in it. Oh, yes. Kim, would you mind? So static web apps are a much more modern and recent piece of infrastructure. Again, I don't have any slides to describe it because I don't want to slide people to death. I have instead an example of one that I have created, which the very first thing you might notice, one of the reasons I was showing you touching upon some of the features and hand waving past, this has a lot less features in it. This is much, much simpler. Okay, that one maybe too dark. There we go. Thank you, Kim. Appreciate your help there. So this is much simpler and is designed and has far fewer options for hosting what is essentially just static code. Now this, again, not trying to assume knowledge on the folks listening. Many of you I know, but some might not. There are other technologies now for building websites that instead of requiring, we looked at all the compute for our web app that ran our code earlier, the CPUs and the RAM that it needed, and it ran the code on a server in Azure. The more modern way of building websites in particular, actually the code is stored in a service like this one, but it doesn't get executed by this. There is no real underlying compute that does anything here. It's all executed by the user's browser. Now, this is a different method, a different technology design on the part of developers who are building websites. Choosing that, there's various technologies that light that up, but this is Azure infrastructure that supports that pattern. So if that is the way development teams choose to build web apps, and it is a very modern way to do it, this is the infrastructure that hosts it. You could technically also, in fact, prior to having these static web apps, you could have this done for you by an ordinary web app. An ordinary web app will host the same code for you, but it is more expensive. It's not going to be doing any work. It's just going to be serving content, and it's still going to be executing in the user's browser. So in many ways, it's kind of a waste of money. So if you have a modern application, what's called a static web app, if you will, a static website, then a static web apps is a much more cost-efficient way of hosting that type of component. So that's the website. That's the bit the humans interact with, right? So that assumes a certain technology and design on the part of the web app. The other component that particularly pertains to APIs in static web apps is that they have within them another Azure service called Azure Functions. Now, we're going to talk more about Azure Functions, which are a standalone technology, but static web apps includes them because the most common pattern for web apps that are designed to be hosted on, that this technology is designed to host, means that there is going to be some APIs in addition. So there's going to be some a UI that a web browser displays, and then some APIs that talk to a database in order for those that website to do what it does. And this infrastructure includes the Azure Functions technology as part of them, on the assumption that that is how you're going to host your APIs. Now, again, if you have your legacy code, like some ancient legacy code, that's not going to work on this at all. You need to completely rewrite all of that old junk and modernize it. The database can stay the same. Same old database, that can be fine. But I need to rewrite my APIs, I need to rewrite my website in order to use this technology. But the cost of this is a lot less. You're paying much more for web apps and app service plans in particular. We're saying that's the part you pay for. Static web apps are much more cost effective. So in a modern website, starting from scratch, this is the kind of infrastructure you typically want to target. This is the newest kitty on the block, if that's the kind of website and API you're typically targeting. Pause there for any questions. I'm skimming a lot, so I hope this is still helpful. It has some capabilities baked into it, like sort of to Ray's point earlier, it has some technologies that mean it has some awareness of back-end databases specifically to help making serving up APIs within static web apps easier, because it's all about hosting APIs and static websites easily. It also has the managed identity feature, but I've cheaped out on my hosting plan on this one. If I upgrade to a better one, then so the standard one stopped being such a tightwad. That one was free. You see, the one I picked, it literally cost nothing. Now there is a free tier of web apps as well, but honestly, the performance of that it's frankly not usable. The free tier of this is very, very usable. It'll work just great. Enabling that, should mean that I'm able to enable the identity feature of this. So this is the default. Click on, save, yes. And this is the same technology as web apps have. And now I have an Azure. I have the ability to assign a role assignment to this. So I can select a subscription. I can select a reader. Now it's a reader of that subscription. Okay, but anyway, so you get the idea. Let's see, there are some networking capabilities that it has and some logging capabilities, and you can have a custom domain. And you might notice this APIs piece right here. So we'll look at that one in just a minute. But this one is one of the newer kiddies on the block. This one also very specifically is expected to tie to a DevOps is how you get this code. Web apps have a few other ways. You can even FTP your code to a web app because it's ancient, it's old school, and that's the way it used to be, right? You used to have to FTP stuff to the web server, and that's how it used to be. You can still do that with web apps. Don't do that, but you might have to. And if you do have to, you still can. Again, legacy, old. DevOps has been for a long time the way it should be done, and that is basically a requirement for this service. You have to tie it to a GitHub or Azure DevOps backend to deploy your code to this thing, and that's what we have attached right here. And I will finish off showing some of the automated API features of this one, because this one has a very cool trick up its sleeve to enable that does a ton of the work for hosting the APIs for our database. Now that I'll finish up with that. So let's see. So I touched upon static web apps, and I hinted there was a very cool feature it has that we'll come back to in a bit, but I need to explain a couple of other features first in order to understand how static web apps leverages them, just tying stuff together. Okay, so that's on the assumption there that you've written, but you have some APIs, and that's some infrastructure to host them. You have another couple of services that you can use to actually create your APIs. And these are, again, these are separate. These are not the same as web apps. They're not the same as static web apps, but static web apps do include function apps, just to be clear, right? So let's just quickly look at an example logic app. We won't spend a lot of time on this one. Oops, I meant to go to my list here. Now, logic apps have a ton of features. You can do a lot of things with them. And I'm just going to hand wave past most of the features of this thing and focus again just on how you might use it to be an API. This is, once more, the Azure portal experience for an existing logic app that I created. And this one, if you aren't a developer, and I just waved all of this code at you earlier, all of this, and you thought, nope, not doing any of that, hate that, nope, 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 then this might be more for you. There is zero code for this. In fact, there is a view code feature that might make you uncomfortable. All the view code is actually this. It's called JSON, JavaScript Object Notation. It's a standard for the definition of the logic app. So this logic app is actually, this is technically what it is. It's this file, one file right here, 62 lines of this stuff. And this UI is generated from that file. And this UI, when I manipulate it, is actually what generates that script. So this particular one I have created as an API. So there is, when I create it, I get a URL, which is internet facing, like so, and I get a URL. This is the front end to my API. So my system, so whatever it is, my web app, my app on my phone, whatever system needs to talk to this system can call this internet facing secured URI created for me by the logic app. And then the next step is one that's sort of baked in, if you will, and again requires no code. This is a feature for SQL Server, and the way I did this is I did add action, and there are hundreds of them. Again, I'm going to hand wave past most of them, but there are a lot specifically for SQL Server. I'm picking SQL Server because that is what our database is. Not that one, where'd it go? This. So our database, where our data lives, is in SQL Server. So the APIs we're looking to create are in front of this thing. So I have gone specifically for what's called connectors in logic apps that know already how to talk to a SQL Server. And these are the various features that I can use. I can send data, I can get data, I can do various things. And I did get, I think was the one that I went, which, as you might expect, takes a connection string that I have to tell it again. Or I can actually use a managed identity, and actually should on this example. So I should use a managed identity, the same technology as we were talking about earlier, to get access to the SQL database. And then which the connection settings passes in the name of that database. And I need to tell this particular connector what table that I want to retrieve data from. And so this, as you might surmise, connects to the database, gets everything in the table orders, and returns it. And then this last step here responds with whatever it got back from this step. So this is sequential. This is the first one. This is hello, give me some stuff. This one is go and gets the data from the database. And this one takes this output from this one, this one right here. This body is the response from this step above it, and sends it back. So we can actually run this one. And see what it did. Oh, I didn't. So these are the outputs of the database. So as you can see, it just has all the data from the database, just pretty much it is the same data as actually stored in the database, just neatly, tidily in JSON format right now, which would get responded back to us. All right, that's it at a high level. The thing I wanted to share is that this is an API without having to write all of the code. I mean, it does the same thing as my ugly code, wherever it went. Gosh, I've lost it already. Where'd that go? Lost it, closed it. Yeah, I closed it. All that ugly code, oh, it's here. All of this. So get order, we pass in an ID, or actually I think it's the first method, this one. All this code right here that I had to write and maintain and compile and then push in the language of my choice is instead encapsulated by that connector in the log caps, which just needs authentication to access the database, be told what table to go get, and it does everything else. So very simple, and as you can see, no code at all is required, which is the benefit of this thing, right? All this infrastructure is hosted for you, and it scales automatically. So very simple, very effective way, and very easy way to create an API. Any questions about this?
Does it do basic transformation, like taking some fields out and whatnot?
So it can do a ton of stuff. This is like the world's simplest logic app, deliberately, right? I didn't overcomplicate it, just a couple of steps. Yeah, this one, the get rows, this is just gonna, as you might expect, we can have other connectors in here that do SQL queries. We can have it execute store procedures, all the usual, right, in order to specify specific data. We can configure this thing up here to have in, see, there's a request body JSON schema in here. So we can alter this to expect things like order ID. I want to know what order ID I want in order to have my function and then pass that value to the next step, which then passes it to the SQL server in order to get back a single record, for example. Easy enough, that would be in here, and then that value would be passed in when you call this logic app. And then your question was about transforming the data. Yeah, we have a ton of connectors that once this step has finished, oops. So in this sequence, I'm just calling it, that I'm not passing anything to it, and it's just getting all the rows in that record. Like I say, we could get specific rows or do all kinds of things, but we can just do all kinds of, let's see, we're doing, and then there's like over 160 different things that we can do. We can send the data somewhere else, we can process it, we can convert it, we can change it, we can make HTML tables out of it. Let's see, many of them are built in, so make PDF documents out of it. I mean, just whatever you want to do. I mean, there's a ton of things, right? This example just gets data center back, just because it's a very simple API. But yeah, if you want it to do a lot more than that, yep.
So is it fair to say that if you're building up a new API, would this be the first, kind of like exploration that you do? Hey, can I use this instead of writing my own code? Or
that's a good question. Would you start with this?
Yeah.
Right. I think, as usual, the answer is. Can you all say this together? Yeah. See, you all knew the
Consultants
answer.
in the room.
Yeah.
What's the answer?
Yeah, it depends. It depends. If you can solve the problem using a logic app, then that's a good thing. You want that, because as you can see, they're very easy to create, They're pretty cheap to run. They have a lot of out-of-the-box functionality. And even as a developer, so as you can see, I've written lots and lots of code. Developers tend to look at this and go, well, I don't want that, because I want to bust out Visual Studio Code. I want to write my favorite language, my favorite stack, whatever it is that I know and love. I want to write a lot of that. I don't want to deal with this UI junk, because this is just JSON, and who cares? I don't want that. But my guidance is, developers, that you do want this for the boring junk. There's some boring junk that you can just do with this thing and leave. And in fact, a common pattern is, we talked about, as you saw on my deck just a moment ago, logic apps is one, functions is the other component where we can host APIs. And so this is a nice segue in that a combination of logic apps and functions is very, very powerful. And that is also something that if you can do it that way, you want that, right? So for example, we can search for functions, Azure functions, like so. And I showed you, actually, yeah. There's a UI to make it easy for me to actually call a function that I've already created and call it from here. So I can actually, if I have an Azure function that includes the logic to do the get orders piece, which I have right here, there it is. Then I can use that instead of this built-in SQL, because maybe there's some magic in there, there's some business logic, or there's some legacy code, or doesn't matter, whatever reason, there's some fantastic code in this logic app. Then in this function, excuse me, then I can use this logic app to call that function. Again, it does its magic, and it returns the results. And then I can continue on and do any other processing that I want. Business processing, make PDFs, send emails, send SMS texts, store it, send it, write it, print it, whatever. Make it. This is, so logic apps, I'm demonstrating how to make an API using a logic app. Functions are also a way to host APIs. And what I'm showing here is a way for an API, logic app, to call another API, a function, in combination. And the reason why you might want to do that is the combination of low or no code. So logic apps are what we call no code. There's no C# or Java or whatever, Perl, Node, anything, JavaScript, you name it. None of that in here. The function app does have to have something, some code. It could be PowerShell, in fact, but it has to have something. And you can, by this pattern, combine those two. So this is a very strong pattern. Functions and logic apps together can save a lot of time and effort and work. Unit test, so a logic app would be an entire API beginning to end, right? So you would call it and you would debug it in much the same way as I have here. So you would have to have a test harness of some kind that calls this logic app as an API. You saw the front end to this thing. It sends it in, sends its payload, whatever it expects. It waits, because it can't do anything else, and then it gets a response, and hopefully it's the right one. And you send it different things in the usual way, but it's very much a black box to your tests, the tests that call it, right? In order to understand what is happening inside that thing, you need to come to this UI here. And these are all the runs of my logic app. You can see I've run it a massive 5 times. Let's pick the first one that I did, just for example. And this UI is a graphical representation of an actual run. So it's like the logs that you might expect from traditional code that could have been called by your unit tests, your test harness, or whatever you've got that's testing this thing. And you can see there are no errors in this thing. So green checks right there, and this gray one means it didn't happen. Didn't happen because it wasn't waiting for a response. But there might be errors here, and you can have and should exception handling and various, patterns and things that should happen in here, and branching and all kinds of things. And they're all shown here. And this is how you would know what your logic app actually did, in combination with being called. Yeah.
Source code integration you want to think back?
The source code integration is going to be, I showed today, that code. So this is, well, you are still going to need to, yeah, so, I mean, that's a good call out, right? What are the downsides to this thing?
Once some non-developer going here and going, I'm going to make a change and not get approval and not talk to the developer that never service. Hot wow, and you have nobody go back to what worked before.
So you can use DevOps. What you use for DevOps is this script right here. So this is your source code, effectively. This is what you can and should put in your source control, GitHub, Visual Studio, DevOps, whatever it is. It's this. You need to build an ARM template and copy and paste this out. Yep. Yep. It's not as integrated, as easy as web apps, static web apps, or in a minute we'll look at functions. Yep. That's really the weakness of this technology. There are not slots. You would have different web apps, functions for different environments. Yeah, that's a good call out. Yep. Yep, it is limited in that regard. You don't have all the power and the features from a traditional DevOps pipeline standpoint that you might be used to from code. Now you can do local development. It does support that. You can, this UI will execute locally. You don't have to run it on the runtime in Azure. Right here, you can have it running on a desktop. It can run in a container. It has a run anywhere thing now, but this script here is your source that you check in. So good call out. Yeah, it has some weaknesses in that regard. This is how you do it. That's why functions are a good combination for this, right? So you would use logic apps for the things that just boring grunt work that you don't need a lot of sophistication for, formatting, things like that, sending of texts or emails, just storing of things. And then the bit that requires more finesse, have that in a function, and that you can have full DevOps for. Which I think is a nice segue into, all right, we've talked about functions a little bit. It does. Yep. It has a whole bunch of alerts and metrics and a whole bunch of stuff, but yep, it will. There's a ton of that as well.
Is there a Copilot coming to this?
Copilot would not really apply to logic apps, really. They are because you create logic apps using that portal experience. This experience, this UI experience is really how you create and edit logic apps. Copilot for a UI, it's too primitive in that regard, right? Code, it makes sense. For the behind the scenes that I was showing, this is what it really is. This is just JSON. It's a template. It's not code. So again, Copilot isn't going to really be able to, other than if you missed a semicolon.
Well, yeah, I mean, I get it. Like, I think I was thinking more about like not the GitHub Copilot, but more like, logically placing these boxes and just coming up with that JSON schema.
Oh, I was thinking of GitHub Copilot.
Yeah, sorry, I shouldn't have said like Copilot, but like, I mean, we're adding Copilot to like a lot of Microsoft technology.
Yes.
Right? So like, maybe a bot or something here, you say, hey, this is what I want to do. This is my database. This is what the outcome needs to be. And it builds up, because he's showed like, I don't know, hundreds of those options.
Yeah, there are a couple of hundred of connectors now.
Exactly.
There's many of them built in. Microsoft wrote them, like the one's example here, but all third parties, Adobe has them, and lots of third party vendors encapsulate their logic into a connector which you can then pay for and incorporate into your logic app. Yeah, for example, there's a whole marketplace for that. I think your question is there a way to, have a logic app be built for you? That's a good idea.
Yeah, I mean, that would be pretty cool. Like, I mean,
That would be
I'm,
cool.
I'm liking this technology a lot, like, because I'm about to write an API. I was about to code
Okay,
it.
yeah.
And so if there's like Copilot, I can just say, like, for example, hey,
Yeah.
create a logic app for me.
We need a GPT model that generates this.
Yeah.
Yeah, we don't have one currently.
They,
We need one.
in Power Automate, they've added Copilot preview to the Power Automate.
Okay.
So
Oh, I didn't know that. Interesting. Power Automate is another set of technologies, business developers type deal, that actually uses this same engine to allow business users, not developers or IT people, to build workflows and access APIs in the same way that business developers used to use, and probably still do, various Excel, VB scripts and things like that to make powerful fat client applications. Power Apps is a suite of technologies for business developers that use this same engine. Didn't know I had Copilot. It's interesting. Okay. Any more questions before? Again, this was a light touch onto Logic Apps, which by itself is an immensely powerful service. It does much more than can be used to create APIs, but our focus is things we can use to create APIs. A more common pattern is more usually seen as it responds to something. So something, you have your Logic app responds to an event. So event-driven architectures, for example, or periodically batches. It wakes up every minute and does something, for example. They're more common use cases. It does those as well. But anyway, all right. So functions then. Where are my functions? So functions are an evolution of web apps. Where are they? Oh, I have them in a different... I think I ran out of money on my subscription, so I had to get a different one. Put them in. Here we go. So in this resource group, different from my other, again, for reasons, we have another resource. This is of a type function app. So this is yet another Azure service that you can use to host your APIs. This service is designed specifically for hosting APIs. That's really what it is for. In particular, code that you write. And it is very similar to web apps in that it also has an app service plan, which is what you pay for. So a similar paradigm. However, the infrastructure available is in smaller units, and the functions, there is a different UI, it has a whole runtime, are separate pieces of code. So you saw this when I used the Logic app to look at this thing, and I think it's actually, ignore that. See that right there? Okay, that hand wave, that isn't there. Basically, my demo broke, and I haven't got a chance to fix it. So I need to redeploy this thing. I don't know why it's broken. But anyway, but pretend for the purposes of the demo that everything works, and we would do get orders right here. And this is an individual method. We can look at our code right here. I think this is a Linux one, so I'm not going to do that. But I have this is a Linux one. So if on Windows versions of these, there is a UI allowing you to actually do some editing and view the logs of this thing in real time. Actually, you might be able to see why it broke. But there is a set of capabilities to allow you to debug your snippets of code. And if I show briefly, so this is very much for so this is my database. I think it was this one. There's my janky old code, which I then rewrote once upon a time to separate it out all into functions. So here is rewritten code. It's also still in C#. Now, functions support not just C#. You can write it in Java. You can write it in Perl. You can write it in Python, actually. Actually, not Perl. I meant to say Python. And you can also write it in PowerShell. So this example, so looking at my orders one right here, is less code. than the old janky code that I had to do. I think the top one, get orders. Let's see, create random order in there, new order. Let's see, it's going to be create, update, delete, get orders. This one. So this represents the code that my Logic app also did. That huge chunk of old code also did. This is a single function. Again, functions are designed to be single purpose, small amounts of code. And they provide SDKs to help developers with common patterns like reading from databases without having to write a whole bunch of supporting code. So I won't go into the weeds of it, but know that this is what we call low code. It's still code, as you can see. So to address your question earlier, full DevOps life cycles are par for course. This is what you do with this. But you also get more choice of languages, and in particular PowerShell. I'll call again PowerShell. Don't need to be a developer. In fact, a lot of folks, business people, know PowerShell. A lot of infrastructure people, in fact. I've worked with teams who, infrastructure people, so networking, VMs, and security, all those traditional data center technologies, never written a line of code, but they absolutely know how to write PowerShell in order to automate their VMware stacks and make their lives easier. PowerShell is a good solution to a lot of problems on the on-prem data center world. So a lot of folks have a lot of expertise in that, but none in traditional developing. Those skills parlay well into functions. You can write an entire function. This one, for example, getting data from a database, you can do it all in PowerShell. Don't need a lick of JavaScript, C# or any other traditional programming language. So it does enable a broader set of skill sets with the same infrastructure, not just for developers, but with the full DevOps lifecycle that you would expect to enable the usual capabilities that permits. I'm not going to go deeper into functions at this point. My intention is to show that this is another choice of infrastructure. You need to use the SDKs for hosting APIs. So this has a lot of scalability benefits. What else was I going to show on this one? It's going to show, it has slots as well, unlike Logic apps, unlike web apps. It also has security features like the managed identity, which can be and should be used in code. Supports some infrastructure capabilities to allow security like networking and scales in and out. Also has an app service plan, which can be used, and this is the bit you pay for, just like web apps. But very specifically designed for hosting APIs in a variety of languages. So this, if you want to write code or PowerShell in order to create your APIs, then this is where you would go. This is the most modern infrastructure to do it. All right, I hinted that static web apps actually include that. So it also includes a feature that I'm going to talk about next called Data API Builder. And then the last feature I'm going to talk about is API management. I started with that in order to try and demonstrate to those who might be new to what an API is, how you might manipulate an API. An API management service is something that would go logically in front of the APIs that you built, irrespective of which of these infrastructure technologies that you picked. Let's talk about Data API Builder. Has anyone heard of it? New to everybody. Okay, this one is, I think this is a pretty cool technology. It's in preview, so it's very new. This is a very new kitty off the block. The problem that this one looks to solve is I've got a database, once again, because we always have a database, right? If we've got an API, we always have a database, same one, something. We have to put something in front of this thing in order to make it easy for other software systems to read from it. So that's still the case. And we've got certain concepts that are native to this database, like this table called orders. I've got a bunch of rows and a bunch of data we need from orders, and we've just shown a number of different ways of getting that same data. We use the logic app to read from this. We can use functions to read from this. I have jankety old code written years ago that just, again, all it does eventually is read from this, right? What Data API Builder does is it's more model-based. So let me show a few steps that I followed. I'm going to put, this is a link to a very simple walkthrough. I hope everyone can see this. That, oops, function, I think I want to do, I followed in order to stand up this tool and do the demo that I'm about to show you, right? So this website, let's just bring that up real quick. Highly recommend everyone have a little play with this one. So this is what it is. It's a runtime. It's some open source bits that you can install, and that's the first few steps of my script right here. So this is how you might do it on my command line right here. So I did it. I've already installed it, so I won't run this. So .NET tool install, like so. In fact, I think I had a, yep. So I had some slides, I forgot. So here's the link. And then these are the steps that I ran on my command line in order to install this thing. There was no, oops. .NET tool install, and then get this. So this is part of .NET. It's a tool that comes with the .NET framework, which is Linux or Windows, whatever you've got. That tool is then called DAB, Data API Builder, and it has a command on line 2 right there, creatively called init. And there are a couple, just a couple of database types supported currently. One of them is Cosmos DB, and the other is MS SQL, which is handy-dandily what we've got our data that our sports league data is stuck in a SQL server forever. And we pass this init command a connection string. No managed identity in this case. We are still using a good old-fashioned username and password. We have to pass it in to this tool in order to make a connection. So it does some initialization. Some magic, actually. Step number 3, we then, as you can see, DAB add orders. So we're doing orders because that is what our table is called. So orders, right here. Same name right there, with a bunch of columns in it, like so. So that's why we tell it, we need to know, the name of the table that we care about. And we pass that to this tool and say, I wish to have permissions, configure yourself to allow me to read data from this table. That's essentially what this is doing. And I would add this command if I wished, and in fact in my example script right here, that's what I did. Cart items, categories, these are all other tables of my database, one at a time, just as many as one. And there's some permissions that I can configure here. As you can see, I've done the easy thing and gone anonymous. We won't dwell too much onto what the options right there. Just we're making life easy for ourselves for the purposes of this demo, and making an anonymous access to this orders table possible for the moment, for the purposes of this this demo. And then we do DAB start. I think I had this up here. So let's see what happens once we do that. Where did I have that hidden? What it creates is this dabconfig.json file. We'll look at this in a minute. This is those commands that I'm going to run here. they create this config file. Let's go to a command line. Go and launch this thing. Make sure, deb, okay. Not many commands, deb stop. Alrighty. So again, it's a tool, some binaries, a runtime, downloaded it. We did some configuration on this thing you saw, not a lot. We told it where the database is. We told it what the table we care about is. That's it. And then we told it to start. There it goes. Now, we can, let me use my text pad, it'll be easier. Now, with just that, ta-da. So this tool has figured out by connecting to my SQL database using the connection string that I passed it and the name of the table, most of the things that it needs to know in order to serve up that table as a API. So that curl I did there is a straightforward get all orders, same thing in one go. So I've done a whole lot of API creating in a few steps. This runtime just does it all for me. Yep.
What did it create though? Is that a function app?
Nope, it's all in this runtime. All it created, I'll show you. I hinted at it. All it created was this file. This text file here, that's this one. This is my notes as to for this demo. And then what it actually created when I went through that was this file, which is this one right here.
So it's runtime or is it node?
It's part of .NET. Say again? I think so. Yeah, in this case. Yep.
Is there a mechanism to deploy that to Azure?
There is. So let me get to that next, right? So this is all local. I'm just showing you this tool, first of all, to give you a sense of what this thing can do. And then we'll see how we might use it in Azure.
And you brought all of the data in orders over. Is there a way to select and an order by and all that other stuff?
Yep. Let me get to that next, Ray. To answer the question as to what was created on this thing, it was just this file which defines the entities. So this one has, because what it actually, this is all we actually need, right? This right there, and the connection string, which is stored in here. There's the connection string, including password, is stored at the top there. And the runtime needs this file and nothing else. Right? This is what it needs, and it figures it all out after that. So to answer Ray's question, I showed just this first example, which is just doing a curl is a command line, create a request to go and fetch an HTTP request. -K means ignore the HTTPS certificate because I'm running it locally, and so running this is what resulted in those orders. This one is, again, calling that very same runtime, which is running here, is running. So that runtime is running here. So this is the runtime in this particular command line right here. I've got another command prompt. And so I'm going to do localhost API orders order ID 1. Oh, that's not what I wanted. I wanted to do call SK. And there I have just that one order. For example, again, all it needed was that one configuration file to define my database. That's all it needed. It figured out everything after that by going to look at it. And then I can get more complicated because this tooling supports a feature which I had it up on my call. See, get my API management up. I've wrapped it in this one. I'm going to show. See this GraphQL? So this is a technology. Microsoft didn't invent this. It's a common standard. I won't get in the weeds, but this is a standard for querying APIs. So similar to, this is really the answer to your question, Ray. There is a technology that if you choose to implement it in your APIs, and that technology is basically a standard called GraphQL, then that enables a mechanism for doing sort of select star type thing against those APIs. Hand wave the details quite a bit. There's a bunch of technology in there, but hopefully that's enough for a high level understanding. So GraphQL, you need to implement that. Those other APIs that I showed, that function, my code, my logic app, didn't have any of that. There's no GraphQL. It was just plain Jane, boring. The data API builder does have GraphQL in it. It supports that. It enables it. And so we can create GraphQL queries. And so that's, in fact, it has an endpoint right here called GraphQL, where we can pass in a GraphQL query, which is this JSON format right here, which you can see looks a little bit like a SQL where statement. That's the intent. Again, not going to try and get too far into the weeds of this technology, but know that this data API builder supports it. You would need to build it if you want that functionality, but data API builder includes it. It comes with it. And so I'm able to make, I think I can actually paste this query straight into my command line. Yeah, no. I can't do it in the command line, but I can do this in my API management. So if you notice right here, API management is coming back to a way of demonstrating how to test these APIs. It understands this GraphQL right here, and I have imported an API using this technology into my API management right here, which I can use to test. So you can see that I passed in queries right here, and I think it's going to be like this. So data API builder, there you go. So passing in using GraphQL syntax and sending it to this API, I'm able to query this API in a similar way to SQL database. So this is absolutely immensely powerful. This is the latest and greatest. This is where it's at currently today when building and hosting APIs. Again, even in crotchety old data stores. No code, no logic apps for this. It supports QueryQL out of the box. GraphQL out of the box. And so again, we're right at this is the leading edge. It's in preview. It's not available yet. So this is the leading edge. And I think to answer the question about, okay, how do we get this in Azure? And I hinted that static web apps have this special capability. I mentioned that static web apps actually do have functions built in. So you can run functions in static web apps. That's a supported capability. The data, and I mentioned also that this is a runtime. You can see it did dab start, and you can see it running locally on my laptop. It's just a runtime. So you could, if you wanted, put this in a VM or anything traditional, put it wherever you want. Run it on anything you want to answer your question, but where you want to do it in Azure is in a static web app, because static web apps include this runtime for you. In fact, I don't think they're even charging for it at the moment. So there is a walkthrough of how to enable that, and I was sort of hinting at it, but it's already included. Static web apps have this runtime that I just showed you in them. So you can create a static web app. It has the runtime. And so I was trying to show the only thing that, let's find it. The only thing that runtime needs is a config file like this one to define where my database is and what the tables that I want it to show. The runtime will do the rest. So by having static web apps run that one time, all we need to do is give that runtime one of these files. So let's find my example. Where'd it go? So I think I had it. Where was it? So it's actually already in the very same web app I was showing, because like I say, it's already in static web apps. And this database connection capability is part of that. That's why it's in preview. That's how it knows where the database is. And so the only other thing it needs is a file to represent what table, to tell it. It doesn't know what tables you want to read from it or the permissions you want to give it. So it needs that configuration file. It has to have a GitHub repo. And so I've got one. So it is this one. I put it up here. Data opioid demo. It's very, very basic. There's almost nothing in here. There is a folder that the static web apps expects to find that file, and there it is, one file. So the static web app grabs this file, loads it, the runtime launches it, and then the static web app will serve it up on an API like this one. That's it. Yes.
So you're passing you have to pass the connection string in that file as well?
You do currently, yes.
Okay.
Yes, which is not great. We don't want that. We don't want that. But it's in preview. It's in preview. Yeah, yeah. Good call out. Yeah, good call out. And so we want to do, I think it was, yeah. So we turn on, and this is a very simple example. It's a static web app, so it includes some static, basic primitive web page, and the web page goes and it calls the data API builder runtime that has been configured with that file that I just downloaded and that connection to the database I just showed, and just returns the get orders and makes it visible in the console right here. Obviously, we'd want it to do something more sophisticated than that, but this is how you get it running in Azure, to answer your question. Very, very straightforward. You could, again, you can put it on VM or something if you wanted, but you want to do it like this because it includes the runtime. Yep.
Only like right now you're pointing it at one specific database.
Yes.
Is there in the future like pointing it at multiple databases on a server, or like, and how does the
procedure that doesn't join across databases?
So it doesn't know about store procedures. It's just tables right now. Mm-hmm. Yeah. Mm-hmm. Or views. It'll work with views. Mm-hmm. Mm-hmm.
You do multiple databases in a view, right?
Perhaps. Yeah. Yeah. So maybe you might want to have, you might need different static web apps per database and join them. And so you have them each serve up the database that you want and then call them separately and then join it. You might need to do something like that to solve that problem. Yeah. So we're right at the very leading edge of writing as little code as necessary to get the same data. We went all the way from, I don't know, a decade ago and all that code I wrote in long time ago in an ancient technology that, who knows, ASP.NET. What even was that? To a very modern application that required no code at all. And you can call this from a logic app, if you want to, but it gives you a sense of how you serve up data from one of the supported databases. And there's not that many. It's SQL database and Cosmos at the moment. Right? So there's only a few right here that it currently supports.
Looking at the website, it does support Sprox.
Oh, I take it back.
But it also supports MySQL and
It could have been in the last couple of weeks.
Yeah.
It's pretty, I think it's,
Yeah, it did not. Last time I looked, it did not support Postgres.
I'll just check it now.
Yeah.
Looks like there was recently some updates.
Okay. Oh, well, good.
Pretty cool.
Yep. That was, yeah, I went on vacation last week, so I'm all out of date.
Go on vacation again and they'll just add more.
Yeah,
features.
that's what happens. Yep.
They'll GA as soon as you go on a long break.
Right. So, yeah, so thank you for that. Thank you. Yeah, so we even more features being added to it. Still in preview. Preview means don't put it in production. There's no SLA, is what that means.
Yeah.
Yeah, you're not going to get support for it. Yeah, if it breaks, don't call, because the answer is you're in an unsupported state, so don't do that. Yeah. And that actually, that completes, the ways we can host APIs. The very last thing I was going to touch upon was API management, a very powerful service all by itself, which is how you would wrap your APIs once you've created them, one or many. And that's why, in this example, I have a whole bunch, all wrapped from ancient technologies like this sports league one to the latest and greatest. So this particular API, these all call against a good old-fashioned web app running that crusty old code that calls the database. And then a much more recent one, this one I was just showing here, this GraphQL one, which calls that static web app I just showed you, which calls the exact same database. So it does exactly the same thing, pulls it from the same data, and serves up the APIs on different front ends like this. And you can have APIs on-prem. It supports converting from WSDL and allows you to change, manipulate, add security in front of them, hide APIs, merge things. So this is a mechanism, for example, if you had two static web apps, each of which pulling from a different database, you could use API management in front of those to serve up one API that merged the results of those two, for example. There's lots of powerful things. It is a mechanism often used for serving up those APIs if you want to sell them. So internal use is the patterns we've been talking about here. A website needs to read data in order to do its internal thing, but maybe you want to sell those APIs. Maybe the products API that we have here, a list of all the products that we have, maybe we can sell that. Maybe somebody wants that. Maybe somebody will buy that because it's got all the content and images and pictures and stuff like that. A common use case is, sign up, get an SDK, have our APIs, and maybe charge for that. So it's a business opportunity. Now, if you don't have something like API management in front, then that's a lot of code that you then need to write to manage who has access, prevent noisy neighbors, make sure that you have the security in place that you need to prevent folks from accessing APIs you don't want them to have, all those kinds of things. Rate limiting, all those problems you would have to write, you'd have to solve. And traditionally, you would have to do that in the code of the APIs, greatly increasing their complexity. And so what you want is instead API management in front of all of those APIs, leaving the APIs as simple as possible with minimal security. If you take them off the internet, which is the recommended practice, so take them off the internet, provide authentication using things like certificates, like I showed earlier, and then provide that certificate just to your API management service and have it manage and control access to those APIs, do the rate limiting, do the security, all of those things, then you don't have to touch your APIs. No code in your API management and capabilities for doing products, subscriptions, all number of features. It even supports as a feature now, if you, let's see, I think it's in this particular example. This particular one it doesn't have the, depending on the tier of API management, you can also have it serve up a portal for your external and internal developers, so to describe those APIs. So a mechanism of showing where those APIs are and what they do, a way of documenting what they are, for example. So it has the ability to serve up a website describing all the APIs that you host upon it. Can't show on this particular one. This particular one is a consumption tier, which doesn't include that because I was being cheap on this particular website. But anyway, if you pick another tier, then includes that feature, and it has a whole some CMS capability, so you can put your company branding on it, and of course you'd lock it down and all the things you would expect. So it is literally a web server that your developers would come to, and even provides the try and test features that I was showing internally here to allow folks to try out those APIs, all baked into the service. So does that sound handy?
I did this for our a POC for our first project, so
Okay.
yeah, it was great. I loved it.
Okay, good.
The content where they can sign up and try it.
Yep, sign, try it, and then you can control how much they can hit it. Yep, yep. Let's see. Has an external cache capability for performance. This is how you'd manage the certificates. It supports having managed identity for those. And actually, this is a new feature. So this Defender for Cloud. So one traditional problem with APIs is that the services used to protect websites, there's two in Azure, the Application Gateway and Azure Front Door, both have an optional feature called a WAF, Web Application Firewall. Its purpose is to look for attacks coming at your website. And if they look like SQL injection attacks or any kinds of nastiness, it prevents those. It's an appliance designed to protect websites from websites that have bugs in their code from being exploited by bad actors. Those WAFs do not work with APIs, don't understand the way APIs work. They're designed for websites, not APIs. Even though it's still HTTPS, it doesn't work. They will generate nothing but false positives. Every cookie you'll come back, it just false positives, nothing useful. So you can't effectively have a WAF, Web Application Firewall, in front of an API because it's not useful. Technically you can do it, but it won't be useful. It won't help. So instead, this feature, Defender for Cloud, is designed specifically to protect against attacks on APIs. So the assumption here is that you have your APIs tucked behind this thing, and this thing enable this feature, and then have all calls to your backend APIs go through your API management, even internal ones, right? Even your mobile app that you own to your API that you own, have it go through the API management and protect it and manage it, secure it, and this feature will protect against SQL injection and all manner of other attacks from outside, as well as inside as well. It's also a risk. So that's the new feature that API management has. There's not another way of protecting APIs in Azure. Not another way. WAFs don't work. Okay. All right, that was a very high overview of API management, and that was all the content that I was going to go through in terms of APIs. I provided a couple of links to how you would enable static web apps here to be configured to use those that data API builder toolkit I just showed, and I won't talk about GitHub and Azure Devs. I showed it briefly. We talked about it. I'll just leave it at that. And I'll leave that. Any questions? Yes?
Yeah, so I'm working on a project where we have Azure functions with connections. Don't judge.
Yeah, it's a good place to start. The key is to know how you should do it and target that. You should use managed identities. Key vault is better. Yep, you can use a managed identity on your function to read from the key vault in order to pull out that connection string. That's secure. Key vault is a secure place to keep your connection strings. Yep.
Yeah, I was actually wondering, how do you debug? I mean, if I'm debugging my function locally, connection strings is trivial, right? But is there a way to debug with a managed identity?
There is. There is a process for that. You would authenticate with Azure, and the Azure Functions SDK has the ability to use the identity you sign in to the Azure CLI with on your local machine as the identity as if it were a managed identity. So if you sign in with an account that has access to, for example, read from a key vault, then it will use the permissions of that account as if it were a managed identity to read from that keyboard. And that behavior is then the same as when it's running in Azure and using the managed identity of the functions. Any other questions? Oh, yeah, I wasn't watching the chat. Okay.
I think you asked the same question you answered already, which is can spur multiple data. This is what I saw up there on the screen, which you answered.
Yeah, some new ones recently added. Okay, thank you. Any other questions? All right, that was a high level. We skipped a lot. I had to try to focus on the API thing. Did anyone learn anything?
Yeah.
A few things? Okay, well, good. No, no, you focus on other things. Think of it as, the way I look at it as in the same way of, developers look at logic apps and think they're skewed. It doesn't solve all problems. It solves maybe some boring grunt work problems. Logic apps can solve some boring grunt work problems. Some of this tooling can serve some boring grunt work problems as well. Still need code and finesse to solve the complex, difficult stuff.
Yeah. I think the important thing is like there's applications that are just really simple things you're trying to do, and you want a fast way to get them started, and then measure to see if it works. Build that. You're done.
Yeah.
If it doesn't work and it doesn't perform, then you replace those parts, and that's the kind of neat thing about this approach that I like.
Yeah.
Doesn't fix your manager calling you at night trying to probably use
There you go.
trying to run it over.
But logic apps have been around.
Yeah, that's why when I was at Oxy, we couldn't use them because it wasn't connected to source control. You couldn't do deployments properly.
Yeah.
It was just a hot. So it's like this island by itself. So,
Yep, you couldn't even develop locally initially. You had to do it all using the portal, and so.
we had a thing where somebody changed it. We don't know why. 'Cause there's no it was just gave up.
Okay, it's horses for courses, as it were. Yeah. It's better, but yeah, it's a matter of choosing the right tool. All right, thanks everyone for coming out. Really appreciate your attention. I hope to see you again next month.
Yeah. Thank you.